Hello everyone, welcome back to VEX, your robotics guide to excellence. In the past two episodes, we talked about gear ratios and the difference between sprockets and gears. So this time, we're moving on to constructing a full chassis. I'll be introducing the parts you could use to construct your chassis based on your needs and take you through the important steps for building. So after this video, you'll get a chassis for yourself and you can try to construct it. Okay, so first we have to consider the wheels. There are many factors for us to consider: the amount, the type, and the position. It is important to plan before construction so you can avoid a lot of trial and errors. How many wheels should we use? In VEX IQ, we typically use 2 wheels on each side, so there will be 4 wheels in total. Since the robots are light, you don't really need 6 wheels, just like you may have seen robots in VEX V5. So let's quickly compare the two. If we use 4 wheels on the robot, it'll be easier to navigate and turn since there are less traction, and it'll also be easier to build. If we use 6 wheels, it'll increase the stability of the robot and increase the friction because there are larger contact with the ground. Typically, we use 4 wheels on VEX IQ robots, but in rare cases, if your robot is too heavy and the axles started to bend, a 6-wheel chassis can help spread the load and reduce the stress. And also, in other cases, you might use 6 wheels is that maybe your autonomous wasn't really stable, and by increasing the number of wheels, increasing the ground contact, you'll be able to write more precise turns and precise movements. Next is the type of wheel we use. In VEX IQ, there are 2 main types of wheels. This one is the traction wheel and this one is the omni wheel. The difference is that the traction wheel has higher friction and grip. So as you can see, I can't really move it. But the omni wheels have rollers, so it allows them to slide sideways more easily. But this one, you really can't. In competitions, we typically use omni wheels on the chassis because they reduce turning friction and the smoother movements usually makes them the better choice. The trade-off is that omni wheels provide less traction, so it can reduce pushing power and result in less precise movements. Finally, it's the position of the wheels. The main goal is to keep the robot stable and balanced, so placing the wheel near the front and the back, like these, it'll be better because the weight is evenly supported and the robot is less likely to tip forward or fall backwards. So a very bad example would be placing the wheels side by side in the middle of the robot. This way, your robot can easily tilt and it'll be really bad. But you also can't really put the 2 wheels too far apart because there will be too much gravity in the center and your beams might bend. So don't put the wheels too wide apart and don't put them too close together. Moderate is fine. And now it's time to decide how many motors to use on the chassis. This depends largely on how many motors are needed for other systems. In VEX IQ, you can use up to maximum of 6 motors. So this is actually a lot. But if you consider the other subsystems like intake, scoring system, and endgame system, just take an example. If you use intake for 1 motor, and you do your scoring with maybe 2 motors, one for transportation and one for putting it into the goal or something, and then you have an endgame. If you have an endgame system of another 1 motor, you will only have chassis. You'll only have 2 motors left. So that's typically how much we use for chassis. If you want a more powerful chassis, sometimes people use up to 3, but this requires a more complicated construction. So in this time, we'll just have an example of chassis with 2 motors. And when constructing a chassis, we need to decide on many things. First, it's the length of the beams. And second, it's the width of the chassis. Third is the gear ratio. And lastly, it's the motor position. Okay, so first what you have to know is that beams are really important. If you want to put a shaft through any part of your robot, no matter it's your rotational arm or like wheels and gears, you will need supporting beams on both sides of the axis. You cannot just put the shaft here and then assume that it'll spin freely. It will not, because in some angles they will have more frictions. And so put it through two beams and now it can spin smoothly. So for example, in the clawbot where the wheel directly hangs outside of the chassis, it's not really good because the wheel might fall off after spinning multiple times, and also after your robot gets heavier and heavier, the shaft will bend, the wheel will bend, so don't do that. Okay, so before the construction actually started, we need to understand the configuration and the parts that we need to construct, right? So first, take out your beams. In this case, just very long beams is fine. I took 20 holes, which is 10 inches. I took 2 because I'm demonstrating one side first. And then take out your wheels. I'll be using omni wheels because driving is important. If you find that maybe your autonomous doesn't work that precise, you can change one of them into traction wheels, but I wouldn't really recommend that because that'll lose some of the momentum during your turning. Okay, so let's take a look at these wheels. You can see there are hollow parts inside of it. And if you test it with a shaft, you can see that the shaft kind of wobbles because it's only secured by one point of connection. And if during your practices there are forces on one side, the shaft might bend, and it's easy for this hole to get wider and eventually become a circle if you only have one connection. So I would recommend filling up the gap. I used a two hole standoff and this black 2x2 beam with the square thing at the middle, and fill this up. There are different methods to do this as long as you get another hole that is square. So don't be confined to this one. If you have other parts, you can use that too. But because I only have the Gen 1 part, so I'll use this. And do it for your 2 wheels. Okay, so next, let's take out the gears. Since this chassis is a 1 to 1.5 gear ratio, so you can take out these gears first. If you paid attention, I don't know, if you have watched my previous video, you'll know that this is the output gear, this is the input gear. So if our motor runs the 36 gear, then the wheel will be spinning at 1.5 times faster than how the motor spins. This is how gear ratio works. However, if we line up the gears, you can see that there is no space in between the wheels, and this is very bad because the robot will tilt and it may not even spin. So we need idle gears in between to make the wheels wider. In this case, I'd like to use a 48 tooth gear because it's the largest gear that you can use for spacing. So you can see that it fits between the 20 hole beam, and the motor will be placed at the center. So let's move on to construction. So first, let's align these gears here. In this case, it's kind of unsymmetrical, but one side it'll have one hole more than the other. Okay, so let's construct our wheels. First, you'll have to insert a shaft. Okay, it's better to place spacers here, so it'll have a gap on spinning and reduce the friction if the gear accidentally touches the beam. Okay, and then let's attach the wheels. Same with the wheels, you need spacers, or else the rollers here will get in touch with the gears next door. So place spacers using these motor shafts or the pins, so your shaft wouldn't move. Yes. And then you will want to place the gears inside this one. You will need to put the motor shaft with one hole here so you can attach the motor later on. And then put it. And then this again, spacer, gear, and then find another spacer that looks like this, and then put it one hole. And now you get a single side beam done. Then we need to connect the other beam on. Okay, so after we put this beam on, we will notice that it can move and we don't really know how wide this is. So we want this to be an integer that can be connected easily. Let's not worry about the gears first, but let's decide the width. Okay, so one really good way is to use these corner connectors that connects two beams together. If you don't have this specific configuration, you can combine it using 3-hole connectors and place another beam on top here to connect the 3-hole corner connectors together. And after we decided the width of this chassis, we'll next have to solve another problem, which is that, as you can see, this shaft still wobbles and the gear moves. There are several ways to do this. For example, you can place the shaft collars on 2 ends and fill the center space with spacers. However, that will need a lot of parts. And now I'm going to show you another way of filling up the gap. First, you have to use a 8-hole beam. If you have this gear larger than 36 tooth, you'll have to use a longer beam, but there will eventually be beams for you to use. And remember to use these really tiny, thinny spacers for each of your gears. And then you'll put this beam, tada! And you can see the wheel doesn't really touch the beams, so it's perfectly fine. After you put this beam on, I want you to place shaft collars on each shaft because you don't want the shaft to move. Alright, and then take out these 4-hole long standoffs. You can place it wherever on these 2 lines. Okay, so before you put this beam back on, you can see there are some spaces between this horizontal plane and the wheel. So you'll have to also fill this gap up with spacers so that it'll be nice. And then you put this back on. Final step, attach the motor. You can place it wherever you want, like this or like this or like this or like like this or this. They are all fine. Just fill up every pin space that you can find so it don't fall off. Attach shaft collars on the wheels because it wasn't secured inside, so you still have to do it outside. Okay, several improvements that you can do with this chassis. First is that you can use a shorter motor shaft here, so you wouldn't have this shaft coming up even further outside from the beam. And for this one too, you can use a pin shaft, so you wouldn't have this shaft collar here, and it'll look better on the outside. So that's just some minor suggestions on how to improve. Okay, so now we've completed this side of the chassis. Let's just imagine that you also completed another side of the chassis. I'll teach you how to combine them together. First, the obvious method is to use these corner connectors holes and attach a attach a beam here, and do the same thing on the other side. And if you want to connect one long beam in the middle, it's really simple too. You can switch out some of these standoff to these corner connectors like this here, and then connect a beam on top, or you can do it here or like here. Anyways, all are fine. In this video, I'll be only demonstrating how to do this side of the chassis, and I believe that you can complete the rest of it yourself. Alright, and that's it for this episode. Remember, the example that I showed is only one possible setup. It's not the only or the best option. There are multiple variations possible for a single chassis that has a same RPM, the same number of motors, or the same gear ratio. So only use these tips that you learned and experiment with different configurations to see what fits your need the best. So don't be afraid to try out different versions. And this is VEX, your robotics guide to excellence. See you next time. Bye bye!